Yesterday, I asked you a question. It's on the page before. And we had this little demonstration and people were coming in and I was all distracted. But my question is, one scenario, you with one of those paper coney cup things under a water dispenser at, I don't know, wherever, filling it up. Is every dimension of that cone, radius, height, circumference of the surface, area of the surface, and the volume of the liquid, are they all changing at the exact same rate?
No.
That's what we decided, isn't it? The water could be going in at a constant rate, but that doesn't mean that all those quantities are changing at a constant rate. Okay? They're going to change, they're going to differ, and yet where we ended was, but they're still related. Just the same way you're different. Did I use it in this class? I think I did. You're different from your relations. Right? You're different from your parents. You're different from your siblings. You're different from your cousins and your aunts and your uncles, etc., etc., etc. You're different, but are you related? Yes. Same thing with these quantities. They're different. They're not necessarily, I should say, they're not necessarily the same. I guess every now and then they might be, but they're related. So, here's an actual problem. Okay? And the actual problem says, we have a conical tank. But in this one, the water's not coming in. Can you tell? What's the water doing? It's going out. And it's going out at, as we read it, well, wait, what do they tell us? The height is changing at a rate of negative 0.2 foot per minute? That's awkward. Whatever. And the radius is changing. It keeps going. Can I just say feet? I don't know if it's grammatically correct, but it's not a whole foot yet. So anyway, negative 0.2 feet per minute, and the radius is changing at a rate of negative 0.1 feet, whatever, per minute. What is the rate of change in the volume when the radius is r equals 1 foot and the height is h equals 2 feet? Does the rate of change in the volume depend on the values of r and h? Here's the system. You read a problem, and you see rates. You see rate, first of all, the word rate, and you see it multiple times talking about multiple quantities. What are the pieces that they're talking about? What are the quantities they're talking about? Radius. So I mark it in a picture and I draw it. This is step number 1 of related rates. We draw a picture of a cone and we say, hey, let's go ahead, and I know it's already here, but I'm going to go ahead and still put it. We make it ideal in the sense that we kind of like close it off, even though I know there's like a little opening at the bottom. But we still close it off. We read and it says height. Oh, sweet, let's label height. Okay, we keep reading. Radius. Okay, sweet, let's label radius. Right? And then it says, what is the rate of change in the... Wait, what? Who's the other person I need to talk about? Volume. Right? Now I'm going to put a big old V on the inside because isn't volume all the water? Okay. Volume. So I look at my picture and I say, hey, I have a volume, I have a radius, and I have a height. Now technically this is actually the third step, but I showed it to you yesterday because I'm asking how can we relate the rates. The first step to relating the rates is relate the quantities. Figure out the relationship of the quantities. So if I see V and I see R and I see H, I'm like, there's a geometry formula that tells me V equals 1/3 pi R squared H. Wait, it has pi. It doesn't have just those variables. Kidding, pi is a what? Oh, it's these. It relates volume with radius and height. Sweet. Now, technically, this would not be quite the next step. The first step, drawing a picture, labeling what you have, and then figuring out, okay, wait, they gave me numbers and they asked me questions. What am I being given? In some books it would say, what do you know? And then, what do you need to find? And in some books it would say, what are you seeking? What do you know and what are you seeking? What do you have and what do you need to find? When they say at the very beginning of the problem, the height of the water is changing at a rate of, I'm being given a constant rate, so it doesn't say it's changing. The height is changing, but it seems to be changing at this rate, nonstop. How could I label it? I just wrote it, negative 0.2 foot, whatever, per minute. This is when you write. Whose rate is it? Height. So guess what? It's ddt of h. Pause. Does that make sense? It's ddt, rate. Rate is further. It's ddt of h, of height. So I call it dH dt. I call it dH dt. If I don't label it correctly, you're not going to know how to plug in later or even what direction you're supposed to go. So height's rate is negative 0.2 feet per minute. And the radius is changing at a rate of, oh, he gave me another one. What else did they give me? Okay, that's what they gave me, but who is it? You can't just take the number. It's not R equals. It's dr dt because it's radius's rate. Do you see it? It's not R. R is take a snapshot, one point in time, and then measure the radius. How big is it? That's not this. This is how quickly radius is. How can you have a negative? Radius is decreasing. It's getting smaller and smaller. It's getting smaller and smaller every minute by 0.1 feet. This must be a kind of big tank, by the way. So then coming back. It's not your little baby cup at a cooler. What are they asking me to find? Some of you might be like, wait, there are more numbers. Pause. What are they asking me to find? There's a question. What is the rate of change of the volume? Okay, you've practiced a couple. How do you think we're going to write rate of change of the volume? dV dt. Find dV dt. Now, hold on. When? Show whens with such that. A straight line down just means such that. So we're identifying which dV dt do we want. Because remember, just because these two are constant doesn't mean he's constant. Maybe he's changing all over the place. So I need to find the rate of change of the volume when. This one instant in time. When what? R is 1 and H is 2. Question, if this water is draining out of this cone, is R always 1 and H always 2?
No.
No. R is getting smaller, H is getting smaller. So this isn't true for the whole problem. These are true for the whole problem. These are constant. These remain unchanging until the water's gone. These are one specific snapshot in time. Okay? Now, what's the problem? If I say plug and chug, you're like, I don't have any of that stuff. Well, okay, you have an R and you have an H, but that's supposed to only happen after you have a dV dt. How do we get rates? How do we get rates? Why, we take the derivative, of course. One more time. How do we get rates? Given an equation, we take a derivative, of course, but what kind of derivative? A derivative in terms of time, because all of these quantities are changing with respect to time. So let's take our relationship of our quantities. Can I zoom out? Let's take our relationship of our quantities and let's figure out how our rates are related. Let's figure out the related rates. But how? ddt. ddt. ddt of one side, ddt of the other. ddt of one side, ddt of the other. ddt of one side, ddt of the other. Now, some of you are really going to hate taking the derivative of the right-hand side, but you shouldn't. You're like, ah, there's 1 and 2 and 3 and 4 different things to do product rules with. 2 of them are constants. So they're just going to chill on the outside while I do a little product rule of only the 2 variables. 1/3 and pi are constants, constant multiple rule. They're just chilling. Now, hold on, wait. I should probably do the derivative of the left-hand side first. What's the derivative of v? Can we do this? dv dt. Because it's technically 1 times, they don't match, dv dt. Equals 1/3 pi, bracket or parentheses, whichever one you prefer. I usually use parentheses, but some of you are being very proper and using brackets. Okay. 1/3 pi. It's a constant. Constants don't cause us problems when we're multiplying. Now we have product rule. Product rule says second, H. D first, 2R. Wait. Does R squared match DT?
No.
No, so I also need a dr dt. That makes sense. R doesn't match T, so I need a dr dt, just like I needed a dy dx in the olden days. Meaning a week ago. Anyway. Plus, all my pictures in the way. Nice picture though? Let's move them up. First, R squared. D second, derivative of H. 1. dh dt, because H and T are not the same. Okay. See it? How are the rates related? Right here. Look, we have the rate of volume, we have the rate of the radius, we have the rate of the height. That's how they're all related. Now we could, I don't know, clean it up a little bit, I suppose. We could say dv dt is equal to 1/3 pi, I'm leaving it out there, 2r h dr dt. I'm not really sure if this is making anything better, but that's okay. R squared dh dt. I'm pretty sure dv dt is changing. Yeah. Based on what the radius is at a certain time, what the height is at a certain time, and then based on how the radius and height are changing. And it's a pretty complicated relationship, but that's how dv dt relates. And some of you from physics would be, oh, that makes sense. If there's less volume, a shorter height, a smaller radius, wouldn't that make sense to be draining faster? Maybe. Coming back. They didn't want the formula. That wasn't the point. What did they want? 1 dv dt at one time. And they don't give us time. They give us R and H. But hold on. Go back to our clues. Look at them. They're all over the place. Right? We have this to plug in. He goes there. We have this to plug in. He goes there. We have this to plug in. And we have that to plug in. Give us your calculators. There's decimals. No way we're doing this by hand. Plug and chug. Bridget, go ahead. You're okay? Huh? Yeah. Plug and chug. So then, at this instant in time, dv dt, such that R equals 1 and H equals 2. Why didn't I plug it in sooner? Because he wasn't constant. Those were always changing. I only plug in at the very end, kind of like those AP questions with find the derivative at a point, and we don't plug in the point until the end. Anyway. You guys are plugging and chugging into your calculator. I'm just showing what you're plugging and chugging. You have 2 times R is 1, H is 2, dr dt is negative 0.1 plus R squared is 1 squared, dh dt is negative 0.2. What have you noticed that I have not kept in with these numbers? I put the numbers, but I didn't put the units. Units might be important. Yeah. Let's see if we can figure it out, though, without keeping the units in, because that would be so much to write. Hey, at least 2 people to collaborate and say, hey, we got the same answer. dv dt equals what?
628.
That's just 628?
Yeah.
Okay, remember, listen, every AP question that you have a decimal answer, you always, as long as it's not like 0.00000000, you always have to have how many places? 3. Always. At least 3. Now, there could be 3 decimal, like here's a decimal, okay? Here's 3 spots. You can either cut it, that's called truncating, and just keep these 3, or you can round it. Either way, you have to have at least 3. Okay. Ryan, why did you say feet cubed per minute?
Because we know that we're dealing with volume, and volume is measured in cubic meters.
Exactly. Without even keeping in and saying like, hey, radius is feet. Height is feet, so that'd be feet squared. DRDT is feet per minute. That'd be feet times feet times feet per minute. Feet cubed per minute. We could put them in, and we could see that. But the problem is, that's going to take so much room. It'd be easier to say, like, wait, who are we dealing with? Oh, volume. Volume, take the feet, make them cubed, because volume is the third dimension, right? All over time is minutes. Stuff is like that. Okay. Let's go ahead and actually write about this process and what we just did, okay? What did we just do?
Oh, no, now it's do it in one.
I'm going to switch the order real quick.
I'm in the intern. I gotta listen to the
Okay. Let's do steps first. Related rates. How do you know it's a related rates problem? You read the word rate. Or you see something changing, like something increasing, something decreasing, like something flowing out of the tank, something going into a tank, a ladder sliding down the wall, a balloon being blown up, a rocket being shot, an observer watching a hot air balloon float up to the sky. Stuff's moving, stuff's changing. And not just one thing is moving or changing, like a single car on a single line, like the motion problems that we did, but we have multiple things changing. Like height and base, angle and opposite and adjacent, volume and radius and height, area and length and width. We have multiple quantities all changing at the same time, but in different ways, but related to each other if we could only be given a formula. Or know a formula from geometry. Good news. AP guys assume that you don't know geometry so hot, so they usually give you the geometry formula. But sometimes you have to figure out how to go in. Or take derivatives, like we just did. Step number 1. Identify all givens and what needs to be found. And underneath this, I'm going to say, and you can just put it off to the side if you didn't have space. Draw and label a picture as much as is possible. Draw and label a picture as much as is possible, especially when you're not given a formula. You have to figure out how to make the formula. Step number 2, write an equation relating the variables, or as I said in the last page, relating the quantities, relating the different dimensions or the different pieces of the entire scenario that are changing. Number 3, use chain rule and implicit differentiation to find the derivative with respect to time t. What does that mean? Take d dt of both sides. There is one quick warning. When we write the equation relating variables, we can only plug in non-changing values. In math or in physics, when we say non-changing, what are we saying they are? Constant, and that does not mean they're a number. I know. You learn constants are forever just numbers. Just because something is a number does not mean that who he is constant and not changing. We're only allowed to plug in, before taking the derivative, constants or non-changing values. Okay, guys, remember, this homework is not technically due until when? So not a bad idea if you try to start and do 1 or 2. Listen to me. I just said what? 1 or 2. No stress. What should you focus on? Forevers and corrections. Sound good? Forevers, corrections, getting caught up. But if you can do 1 or 2, I think some of them are videos from the people we like. That might help you be more ready for when we really bust things out. Thank you. Have a good trip. Have a good race, my cross country team.
Second.